We're gonna get started here. Want to thank you for coming. This is the first meetup we've done in roughly 2.5 years. I've had a couple people say they were here in like whatever it was, late February of 2020. So that is obvious how that happened. Very excited to be doing this again, and very thankful for the project team for Heartwood to volunteer to take their time to present on the project. I'm going to keep the introductions really short. Real quick, my name is Schmidt. I do outreach and education for our group based out of Oregon State University. That's Tallwood Design Institute. Our director, Ian, is there behind the computer. We are a collaboration with University of Oregon, for those of you who don't know, and we focus on research and education in the mass timber space. We've been running these meetups since roughly 2017. So we've been doing it for quite a while. And yeah, glad to keep them going. Project team. So we have our good friend William Silva from Swinerton Builders joining us. We've got Lauren Magasko from Timberlab. We've got Jongeward from BCI Engineers, Susan Jones from Atelierjones, and we've got Megan Doran from Atelierjones. I think they'll give themselves a little bit more thorough of an introduction, but as you know, we're going to be hearing about the Heartwood project in Seattle. Real quick, if you don't know where the restrooms are yet, they're quite a ways down the hall this way. Beer, wine, cider will start being served at 5, so you're welcome to sneak out and grab one of those, bring it back in at any point if you like. And then after the presentation is over, we're going to open it up to discussion. So we'll do kind of an informal Q&A is how we usually run this. Any questions about any of that? All right. Then
basically one thing. So we have about 30 people on Zoom as well as the folks in the room. And I just asked about the audio and they said it was great, but just to be aware that there are these people out there. When we get to the Q&A period, please speak up and slowly, just because we're told the room is wired nicely, but you never really know. I never really trust these rooms, having done a lot of hybrid events. So we'll just kind of play it by ear when we get to the Q&A and the discussion, and we might actually pass out a handheld mic if folks on the remote connections can't hear. So just like that.
Yeah, no, thanks for reminding. Great. All right. Well, we'll just hand it off, and maybe we'll start with William.
Well, actually, I'm going to start with Susan. She actually started this work on this.
Oh, I'm Susan Jones. I'm an architect from Atelierjones. Yeah, I signed the drawings from Heartwood, so that's my major.
No, maybe the back and stuff.
Well, I'll talk about the code stuff later.
Okay.
I'm going to pass it to Megan, also from my office. So, I sort of done interest, but I'm Megan Doran. I'm a project architect at Atelierjones that came out here from the East Coast to really get into the mass timber and sustainability options that are out here and jump in head first. And survive. Apparently.
So I'm William Silva, Director of Pre-Construction with Swinerton Builders. Just been really excited to be involved with mass timber projects, particularly over the last 6 years. And I feel like 6 years in mass timber is like 3 lifetimes in some ways, but it's been exciting to really see this project come to fruition, because I think this is one of those projects that the success of this project is something that we're going to be able to leverage forward into the industry, and in particular how mass timber has applications, not just in housing, but we'll talk a little bit about the project and what it is and why it's so critical and how it's being considered. So
I'm Lauren Magasko. I'm a digital construction engineer with Timberlab. Been working with mass timber for 3 years now, half as long as William. Just one. Yeah, and actually most of my time at Timberlab has been working with this project. Really exciting. It's been awesome to know this team.
My name's Jongeward with BCI Engineers. I'm a principal there here in Portland, but we do work kind of all over the country, mostly up and on the West Coast. And we've been working on a lot of mass timber projects over the years. I probably go back even older than William in my math timber, which is saying something. And yeah, I think I just love problem solving. And right now there's a lot of math timber problems that can be solved. And I enjoy taking my stab at it.
Yeah, it's definitely a lot about puzzles. We love puzzles, you're in the right room, so. As many of us know, it's great to see so many friends here across the board. To figure out where to point this. We always do this at the beginning of every.
You can hit the keypad for now.
Arrow, classic arrow.
Yeah. It might work now too.
See, it always just takes Evan's magic touch, you know, there's the gift of starting back to in-person meetings, so. One of the things, if you've heard me speak, that I feel very strongly about it is so foundational to success, particularly in mass timber projects, is team formation. And we were just really blessed on this project to have a really strong team. Everybody from Community Roots Housing, who has 45 projects of workforce and affordable, primarily affordable housing projects, largely in the Capitol Hill area of Seattle. And they were willing to take the leap, and Skip Stone, led by AP Hurd, she's absolutely brilliant. And what a tremendous partner working with us. Swinerton, Timberlab, Atelierjones, ECI, and Jimmy were all kind of key to coming together, but a lot of understanding of the Tallwood Code was really critical, because this was the first Type 4C to come through the city of Seattle. And so really applying the new code was an effort, and as we know, some jurisdictions are easier than others, and Seattle is not in the easier category, but past relationships with the city, really good land use attorney, and AP and Susan and their connections really helped move that quickly. We did design in parallel to the master use permit process, which was key to accelerating the delivery of the project. That was one of the goals for the ownership. But it really started with a Wood Innovations grant that Susan had secured. And there's a great story that hit up Susan afterwards to talk about her calling AP as she was heading into the wilderness on vacation and say, hey, do you have a site? I have a grant. We want to study mass timber. And so from that, the team kind of started to pull together and really find the path forward on the project. And there were some interesting things along the way that you hear more about from Adam about fire adequacy and some of the things that had to be tackled at that point in time. Because those of us that have been in mass timber and those interested in mass timber, there's a lot of evolution that happens quickly. And I find that it's an exponential pace on an annual basis. So year over year, I always tell clients, like, this is the condition now, but this is what's changing. So it's like having your finger on the pulse and having meetups like this and having Tallwood Design Institute as a way to go to resources is so key to staying in step with the mass timber and the projects that they are. The building itself is 67,000 square feet. It's 126 units. It's workforce housing, and what's amazing is the jaw dropper on it is there is no public subsidy in this project. It is a private finance deal, and it is largely targeting 80 to 100% AMI. So a lot of the people that are in this room would be eligible in Seattle to potentially, live or rent a unit in this apartment building. So really phenomenal spaces. It's something that I think kind of brought it home to a lot of our team members as we went through the development of the design. The lateral system you will learn a little bit more about is a bucking restrained brace frame. And the building type, as we mentioned, is Type 4C, and we'll chat a little bit more about that.
Yeah, thanks, William. I just want to step back and acknowledge this. It's been incredible. And to handpick them
for that grant. And then to fast forward to be surrounded by Atelierjones, especially been on this job since day one. And we'll be on this job until the very last CFO is signed. I just can't. This journey began with these codes, but it began even before that, when about 10 years ago, I started designing my master house. Because of that, fast forward to 15 and 16, I was asked to be on this code right here, and it's one of the hardest things I've ever done as a professional. And sit with these amazing minds, 18 of them at the table, with very disparate backgrounds, and coalesce a language, which I've talked to this group about before in the past, come up with some 200 pages of code, which then, as an architect sitting kind of half awake at this big conference center table here in Chicago O'Hare, to think about how do we actually build those connections, those fire connections that need to be sealed, and how they can look. Oh my God, I know they have to be sealed. I don't know the exact detail. I'm dying to know it. And then fast forward again, 19 when they were passed, to 2020, and I'm sitting at the table with like all of this team, Adam, thank you, to really understand that detail and to bring it into reality, bring it into life, and then go sit in front of the code committee at the city of Seattle and say, this is what we meant, this is what we're going to do, and it's going to work. And it was an incredible journey of 10 years. It did this point in the world. So with that, I'm going to turn it over to my awesome project architect, Megan, and she's going to go with me. Just for a little reminder for any of you code geeks, that's type 4A, 4B. We're down here at 4C. Can't wait to do this again. One of those. Thank you, Megan.
Right, I mentioned that not familiar with Seattle. This project is located in Capitol Hill, which is just adjacent to downtown. It's my personal neighborhood. I live just blocks from here, so very familiar with the area. Capitol Hill is a very dense and vibrant neighborhood, but it is typically mid to low rise with a few scattered single family houses. So this is our site. It's on a shared site with existing affordable housing building that is operated by Community Roots Housing. And that building is a 30% AMI, completely affordable building. So creating a very respectful and dignified interaction with that building was vitally important for our new project. And we did that through this shared entry courtyard between the two buildings. The exterior of this building is quite simple. It's a very simple massing. What this type of post too, but it's also efficient in our reduced glazing and packed size that just helps our energy performance. And we're putting the focus of the design on that pedestrian level, where you're getting that human impact. And mainly in that way, we're creating these stooped entries on this ground level for micro retail, and putting that sign up where it has the most impact. So you can see the site plan and the typical floor plan. You can see better that connection from the street through the shared courtyard into these shared entries to LP here directly across from where we're situating our entry. These units are on the smaller side. They're on average about 400 square feet, 126 units total between studios and one bedroom, but mostly studios. Here you can see that typical studio. So each unit has at least one set of exposed columns and beams. And on the other side, consolidating all of our surfaces, starting to encapsulate some of those columns. But exposing the wood where it has the most impact. So even though these are only with a roughly 9-foot ceiling, it makes that small studio space feel really large when you've got all that exposed. Yeah, wood where it counts, where it has the most impact. In these units, we where you're locating and installing all your services starts becoming really important when you have all these large exposed ceiling areas. So being really smart about where we're placing everything, where we're routing everything allows us to expose all of the ceilings in our corridors. And expose as much of the unit as possible. And here you can also see where we're encapsulating every other column line. So that helps us in a few ways. One, it's a good place to put our services, but also it saves us a little bit of wood fiber. We're able to size every other column line down. And through some LCA studies that we did with the Nature Conservancy, we found that the structure of a mass timber building, an 8-story mass timber building in the Pacific Northwest, 43% less carbon than its comparable concrete equivalent. And we are underway on doing a specific LCA for Heartwood to get the exact numbers for the project for a typical project. And major components of this building, you can see all of that mass, that biogenic carbon in the wood, and a relatively small volumes of concrete and steel that we are using. This is a seismic area, so we still do have some steel. It is in the end a hybrid building. See how much that concrete in particular is reduced, and then later on we'll talk about our 2-hour wood joint. Again, we're trying to remove the steel from that connection and even lower those high carbon impact materials.
Okay, so one thing that we wanted to figure out really early on is figuring out ways to harness speed of the mass timber. I feel like we talk about this every time we talk about mass timber, is knowing that it can be erected fast. You have to have an entire system that can be erected fast with it. And so we hypothesized what would it look like to have concrete walls that we have in the lower left-hand picture. And while concrete walls can maybe go up really fast, you can fly them ahead of time, like they've done in this picture. We have kind of an L-shaped building that has a core on one side and really wants a straight blade wall on one side of the L to balance the torsion. And so in another project, we have an example of a 4-story concrete core, which is all self-supporting, and a 4-story blade wall, which is giant. And these braces need to be there in order to brace it during construction. And those braces, like, they look kind of big until you see a man standing there. And you're like, oh my goodness, like those things are gigantic. They have to pour a temporary footing on the backside just to brace the wall. So while it has its place, you know, if you had a building that merited 2 cores, it might make a whole lot more sense. But in this building, it really just didn't make sense. And so we also thought about what it would look like to use wood walls and use some sort of CLT wall. Totally possible, but not codified currently. And we wanted as few kind of hiccups with the permitting process as possible. And so while this is possible on the West Coast, there are certain challenges with it. So we decided to not tackle it here, but it also has bracing requirements, but probably less onerous than concrete. And so we landed on BRBs, which is steel columns, steel beams, and a steel brace. That's proprietary. If you want to learn more about BRBs.
Slide. Yeah, you know, a question that a lot of times we think about speed, right? And mass timber is very quick, and you would say, why would you advance all those concrete walls ahead? The reality is, mass timber can catch concrete so quick, and if you try to do the concrete a floor at a time as you went, it would be so disruptive to the speed and the efficiency that you get with mass timber that's why it's really it creates an additional challenge to the delivery of the project. And the blade wall is the perfect example of, it's not only takes those braces to put it in place, but then you've got to build the structure around those braces. Then you got to pull those braces, you got to thread them back out of the building. So there's a lot of complexity to that. But we've got another project that we're doing in Northwest Portland right now, which is 4 stories, but the shear walls are 2s. And so while the wood was being ordered, detailed, fabricated, we were able to build the 4-story walls. They were self-supporting. And then we could really just bring the timber in and marry up. So it's something that, as you look through lateral system selection, is really kind of pre-thinking that as you're making those decisions really in schematic design. And so we highlight that to teams to really think those through. But all in all, there are a lot of great solutions to kind of the buckle string brace frame. It doesn't have the same carbon intensity as concrete. And there's a lot of ways to detail it. Really, if you drill down into the floor plans, Atelierjones did a great job of locating those in places where they could be both self-supporting and be strategic to the delivery of the overall structure. But it's kind of like thinking through all those dynamics in schematic design, really layering on decisions taken by a collective team. And that's one of the things that I think we emphasized in the beginning, but it's having that thought process of engaging specific ideas like.
Absolutely. So we talked earlier about it being a hybrid structure, and so we landed on the main steel elements up the middle of the building are these BRBs and the supporting columns and beams. We have a couple transfer beams at the ground level that are steel, and then there's a series of steel straps and plates that are collector elements to bring the load in. And it's, while I love wood for what wood is good in, it's not great at having really strong, really compact connections. And so use steel where it's needed most. And that was, this is how we landed. There are some lessons learned here that we'll talk about in a bit, but that's where we're starting. The one key tenet of this project was to figure out ways to use wood where it makes the most sense. And one thing that we heard very early on is that steel was costly to fabricate, steel was costly to fireproof, steel was heavy to erect, and it doesn't really look that good, especially fireproof steel doesn't really look that good. And I was like, well, seems like steel is not a very good solution here. Like, what if we just came up with an all-wood connection? And they're like, that sounds great. So we just like going back to basics, just cut what we call a shoulder out of the beam, and we just bear the beam on the shoulder. And this is like mortise and tenon joinery that they did, in Amish country, hundreds of years ago. And just like, what would it look like to do this? But we could size these elements, we could size this bearing ledge to allow for enough char that as the column is shrinking, you're still allowing enough bearing for the beam on the column. What happens if we didn't want to have it peppered with screws? What happens if we just wanted 2 screws at the top, but we wanted to make sure that it would never roll off the column? And so adding in this tenon just provides internal stability all within the wood that keeps it intact even in a fire. And so there was a lot of, the engineering of it is like pretty simple, and oftentimes I feel like those are the best engineering ideas, and so I tried not to like overly complicate it. But in my opinion, the most complicated part of this connection is figuring out how it's actually going to come together and actually be built. I don't want to like bring out the old like Amish hand tools and be like, this is how to make a mortise and tenon. And so we need to figure out ways of doing it in a CNC machine that is fast and has enough tolerance, and knowing where those bits can get, knowing what tools were at our disposal. And so there was some back and forth on how actually this was going to be built. And then there was a whole bunch of back and forth on how exactly we were going to seal up all of the joints. And when the fire comes and engulfs the column and the beam and the panel, how do you make sure that fire doesn't sneak into those joints, because there's nothing stopping the fire from doing so. And so what we landed on was a series of notches kind of routed out in the column and in the beam. There's some other ones in the beam that I think we'll see in a bit that use intumescent tape to seal up that joint. If heat were to ever get to the joint, that tape would expand and seal the joint accordingly. And so we made a mock-up in the factory, and Laura maybe has some some additional insight there because I feel like the mock-up was key in figuring all of this out.
The mock-up was definitely key, and that's kind of where Timberlab came in. We, modeled everything down to fabrication level and ran these pieces through our CNC machine. And we tested out various tolerances for this specific cut, especially around the mortise and tenon. Oh yeah, and so this is actually a few pictures from our mock-up that we did, and we did this very early on. We also looked at how the tape was gonna fit in these notches. So you can see we have the tape around the top of the column, as Adam said, at the beam ends, where that beam is gonna be attached to the column, and where the column and the CLT are gonna meet. For this, we also were able to figure out how much time each piece was gonna be put in through our CNC machine, how much time it was gonna take to fabricate that, all the columns, all the beams. And then we can kind of like factor that into the available time that we have when we need to start that before everything needs to be then on site. Yeah.
I never gave that to you, sorry.
Now, okay, William.
I'm gonna do that for a second. Tell you, whenever you went through whenever you returned somebody from the Timberlab facility, I would always ask Lauren to join me because the energy of like, just, going through the detailing, the fabrication of this. When you really look at this woodwork and joinery and having that on a CNC machine, it's the opposite of what Adam talked about. It wasn't the old hand tools to make the mortise and tenon. It really has beauty in its simplicity, but also how it responds to code, fire tape, how that works. The team found that together. It's been really amazing to see how the application here and the elimination of some of the costs, eliminating the steel and the connections saved $5 a square foot on the overall building. It's a very significant savings and it led to a lot of structure.
Yeah, and just to actually that by eliminating all this steel, that saves us in any kind of hand fabrication, pre-installing any connections on these columns or beams. So that was a huge time saving in this whole process, and it also saved time in our detail. That's just one less thing that we have to detail in our fabrication model.
So training to something a lot more boring, but really, really important is thinking about the cash flow on the project. Because again, we're working with a nonprofit, community roots housing, amazing client. But when you talk to a developer, whether it's a private developer or a nonprofit agency, one of the things that you have to socialize them to is the cash flow, because with mass timber, there's a timber deposit. And I think it's real critical to understand how that is up front, because most clients will not be in a position to fund that deposit out of pre-development funds. And if you think about it, it's the difference between the mortgage, the rate you would pay for the mortgage on your house versus the cost of putting it on a credit card. Pre-development funds are more like the credit card. So you really want the financing for the project to close to do that. And so as we think about that specifically in the application of Heartwood, we had to get to a point where we could guarantee the project so that they could close the loan. As you can see, so GMP executed at the beginning of November and be able to place that deposit within 30 days. But there's a lead time then associated with the timber, and Heartwood is an on-grade structure. So there's no substructure for you to buy you time in the delivery of the project. And so the start of the project is being driven by securing the wood and having it detailed. And so the strategy on this project was really getting that financial close. And Susan likes to talk about the day that usually the architect gets the permit, because the permit happened right before the close. And yeah, everybody take your planned vacations because we're about to start the
I
project.
had promised Ian a vacation for this month, and I said, no problem, we're working hard until October 24th. The GMP signed November 4th. I know we're not starting construction out here. We've already done 90 BIM coordinations. That little pre-con up far, that's already about double what it would have been normal. So it's not just like the deposit. And all of a sudden, like, oh shit, Ian, I gotta honor Ian, but he's gotta go on vacation, and he did. We did want to go on vacation, but we had to scramble in November and December to make up for Ian's well-deserved rest.
And get back on track and keep answering those RFIs, Taylor and Lauren and Gail. In order to have everything on site ready, it was, the basic CA stuff is kind of in this period. But when we hit the ground, things were happening flying. If you hadn't had that concrete strike for 2 months, which is not a lesson learned, that was just a bummer. We would have been even more in more trouble in some ways from our perspective. But that kind of planning as an architect, as somebody running the firm, we don't often grapple with that granular level of that need. And it's just a word for the wise, in the future. Just remember, CA starts to sign that.
Yeah, and it's true. It's more than just the mass timber. Mass timber starts to be the chassis of the building. But because of the pace of the project, essentially we're delivering this project in just over 12 months. And so, and envelopes in there, that lateral frame, all the steel, all the detailing, all of those
The
things.
toilets were on a
Yeah.
big supply chain issue.
Right, and so a lot of that's happening in that first 60 days. So while that's happening, Timberlab was working hard to get the billet release, to get the materials coming and get it into the fabrication to hit the install. Because again, we were thinking, get the foundations down and start erecting timber. And the curveball that the market threw back at us, and there were a few of them, was that Teamster strike up in Seattle that some people know about, painfully so, but others may have heard rumors of. But that really kind of disrupted our flow. But this was like the overall plan for the delivery, and that's kind of what you have to be prepared for. And that manifests on other projects.
So this lovely map is done by the Atelierjones team.
Done by Ellen.
Yeah.
Thanks.
And this really shows how local we use our materials. So we use Ballistic for our CLT panels up in Canada. When they actually ended up fabricating all of their panels early because of the strike, and so we had to hold that material down in Spokane until the project got going. We use DR Johnson for our glue lamp, Ferris for our MPP stairs. And then we did all of the glue lamp fabrication in our Timberlab facility here in Portland. So you can see that all of our material and all of our services in 300 miles or so from the site.
And I can't say enough about how Timberlab through this timber forest and really thought about it with our leadership as a regional solution for mass timber, because this 400-mile radius represents an entire biome, an entire ecosystem, both natural and human. And we in the Northwest, all of us in this room, and thousands of other people around this area, really deserve a tremendous credit for building up this ecosystem, buttressing it and bringing it forward into really full-scale international level of 21st century timber. It's not only the timber and the post-processing and the buildings, but it's also the forest and the wood. And most of these companies, all of them have. I visited Perez Forest, I visited Lishman Fox Forest, I visited Johnson's Forest. Many of them own forests, manage those forests, they have long-term contracts, and that makes things like price procurement much more easy when lumber prices are spiking. Contracts and this entire ecosystem, human and biological, extraordinary achievement that we've all been partaking in. Where are you? Thank you. Just over the last decade, and it's really sprung from that forest.
And with all of our suppliers, you can see the capabilities that each supplier actually has. So we've highlighted obviously all of our suppliers and our capabilities. We did a majority of the 3D modeling and prefab and the hardware install, whereas Ballistic also did LT fabrication. We provided them all of the 3D files for them to use. DR Johnson, they provide glue lam, and where everything is FSC certified. But these are all just our local suppliers that we supply intelligently with all the time. So during the design of this project, we focused a lot on the BIM coordination and collaboration with all of the MEPF subcontractors. So we put in a lot of effort into coordinating and making sure we had all of our penetrations in place prior to fabrication. The goal is obviously to avoid any kind of penetrations on site, having to cut any wood on site, want everything to come prefabricated. But we also had to deal with a lot of clashes, and there was, how many meetings did we have? Like this,
Oh, I say 90, that was 6 months ago. So, or, you know, yeah, I think it was.
That's good, man.
and then we were still coordinating some last minute
We still have a lot.
changes.
It was a lot.
Even through until the last minute, basically. But you can see that this coordination is well worth it, and comes out, everything on site comes out so clean. And looks so much nicer than having one come in. That's something.
And I think for the trades, mechanical, electrical, and plumbing are a challenge for sources and power.
Yeah, it makes their job
workers
so
on
much
site.
easier.
Not having to have an electrician or a plumber or drill a hole is such a phenomenal benefit to them, even for interior partition layout. They'll almost know that if you lay out, if there's not running a plumbing wall, that maybe the layout is the wrong place. So there's a constant refinement and opportunity for our industry to really kind of leverage this whole.
So another aspect of this project was the MPP stairs. So not only do we have CLT and glulam in this project, we also decided to make the stairs wood as well. So this was a fun aspect to design. You can see a few good details here, but I think these are my favorite pictures where you can actually see the grain of this MPP. We basically cut it out of this 9-inch thick piece and cut out the rise and run from there in order to get this really beautiful look. And I mean, right now, this is the rise and run are covered by protection just for the site install, but it's all going to be exposed even down to the guardrails of this stair. So it's going to be really, really cool when you're in the building.
But I feel like, in my opinion, it is great to have it at the end of the day, be mass timber, but I feel like the logistics of having it be flown in with a crane, just like the rest of it, is like allowing your workers to use the stairs. You're not paying for scaffolding. You're not like finding space for a temporary stair and then eventually coming back and building it. I feel like it's more than just the final product. It's all of it, like all the way through.
Yeah, we installed these stairs as the building was going up, and they used these stairs as.
I think that's the thing I wanted to pull back to a little bit is that thinking about these, it's really amazing to have those stringers and have that access to it at the time because you're not waiting for permanent stairs, you're not putting in temporary stairs. And I think it's also an indication of the team when you're thinking about, and the structural engineers talking about site access for construction, right? Not everything we always hear, but I think that's where I talk and sound like an architect at times. But I mean, it's kind of like trading those things off that really make teams work better as we're all thinking holistically about the project. And that was critical for this project because of the site logistics. And if you look at this site, I mean, it is a tight urban site to start with, and then you start removing access in your mind as you think about this and how you're going to build this. You say first, oh, there's an alley on the west side of the project. Oh, well, that's a private alley. You can't use it. You can't step foot on it. Oh, okay. Well, you're right there on Union, to the right, on the north side. Well, that's got high voltage lines, so yeah, you can't use that. Oh, wow, you've got Helen V on the south side, that you're essentially minimum separation between the two so that they're there. And by the way, that's very low income housing that's owned by the owner. And so, you know, you already have respect for the client of the tenants, but literally in our OACs every week, the manager of that building is in that call. And we coordinate all aspects of the access to the site And, Megan even mentioned on the entries, there's 2 entries. One you see right here, under this, entry, and the other is in this corner. And you think, great, I can cut off access to one, right? Because there's got to be a connecting corridor. No, it's a really old building. There is no connecting corridor. Both entries have to be there, as well as this entry right here in the basement. Those are the 3 ways into the building. They have to be open all the time. And so logistics of even getting the substructure in and getting the electrical room, the electrical bulb, everything is very tight fit to the project. And so finally you come back to the east elevation and you say, saving grace, we can access the site from the east. Well, there's a tree there that's really faint down in the corner. And by the way, you can't have that part of it. So really, the window to the side is between the tree and the building. And so you think about the viability of building on this site, if it wasn't mass timber, is very low. And so even early studies that Atelierjones did said you could probably get 80 units on this site, but by working together as a team, we got 126 units. And the main goal for community growth housing was a lot of their affordable housing with public subsidy can take 4 to 5 years. Is that fair? 4 to 5 years to get land use design, funding, tax credits, all of that.
3 years.
But 3 years on that, and then a couple of years to build it, 5 years to deliver units to market. So community roots housing said, hey, can we go workforce 80% to 100, and can we deliver it faster? And so you got through the master use permit in 11 months.
11 months, which
Yeah.
was a record for me, one of the records for Seattle.
Yeah, so that's where the bar's at, so she has to go faster than I.
Thanks.
But the reality is to run that and design in parallel, and then to deliver this building, all of a sudden you're taking, say a 5-year processing unit, you're turning it into a 2-year process. You're delivering 126 units of workforce housing to a market. All of the West Coast cities are starved for workforce housing. And so to be able to do that in an urban setting with this kind of site logistics, every move you make that helps improve that outcome is critical to project success as it's defined in the bigger picture. And so Adam's point about even moving workers on the site, you can think we barely have enough room for scaffold, let alone a scaffold tower. And you can see how the tower crane is exactly where it has to be. It is very tight. So I think that's really critical. The other thing from bringing panels to the site is thinking about how CLT panels get to the site. And we really work together to reduce the amount of oversized load of long panels and getting them delivered to the project.
And talk about, what you do in schematic. We did these kind of drawings in feasibility studies or schematic design before we had a full contract. We had layouts to ensure just the architects even, but checking them with all of you. This is a Timberlab drawing, but yeah, we knew that there was.
But as we know, it's like getting those long panels. There's restrictions on moving through a major city to have those be able to erect into place. If we'd gone with longer panels, that might have been more efficient structurally, but that would have really impaired the schedule because of the restrictions on being able to bring oversized loads to the site. So we wanted to prime the pump for the Q&A because we like fastballs and curveballs. So no, the reality is we really wanted to share some challenges and successes on some specific points to really set up for the Q&A session and really talk through that. Adam, I think you're going to start us off.
Okay, so early on, we did a bunch of studies on various panel manufacturers, and we landed on who we could get the right size at the right price at the right everything, and that was Katerra. We had a permit in hand with a Katerra panel listed on our drawings. City of Seattle is really clear. You cannot have just a generic CLT panel. You have to pick a manufacturer. We picked Katerra and we got it approved. And part of the reason that we got it approved is we were able to use their E119 test to show the 2-hour char capability. In the code, you guys probably all know that there's several ways that you can show that you can meet a 2-hour rating. One of which is doing a calculation, which is oftentimes how mass timber buildings go. The other of which is doing a test. And so we didn't have to fight anybody about the calculations because simply we had the test and it was like, we got it. Then, as you know, Katerra decided to close its doors and we had a permit in hand, but we hadn't started construction yet. And I got a call from the reviewer saying like, so what are you gonna do now? And like, we're gonna get creative. And so what we landed on was eventually a Kalashnikov panel. We picked them for several reasons, all the things that we were evaluating up front, which is panel size. They had all the similar sizes, all the similar thicknesses, all whatnot, but they didn't have a fire test. And so that turned into a pretty big hurdle. If you go to the next slide, whoever's holding the thing. So really simple charring is glulam chars at a non-linear rate, something similar to this. Over time, as it chars, it builds up that insulation layer and it slows down. And the code says currently that CLT doesn't do that. CLT, when it hits a glue line, that piece of wood could fall off and then you're burning fresh wood again. So once you hit the first glue line, you start to burn at the faster rate again. And you burn at the faster rate until you hit the next glue line and then you restart at the faster rate. And so glulam burns slower than CLT. However, in 2018, they changed the code on rules for how adhesives work in CLT. Essentially, they got rid of the delamination problem. So in my head, I was like, oh, we no longer have to do this. We got rid of delamination, but not changing the code. And so we reached out to the AWC and said, hey, are you guys thinking about this? And they're like, yeah, we're thinking about it, but we don't have enough US-based testing to change the formulas yet. And I was like, well, shoot, like, if you go by the calculation, you have this much char and our grid doesn't work. And so we would have to redesign the entire building with a tighter grid spacing. And so we got them comfortable using a handful of tests, some out of Sweden, some locally here. We got the city of Seattle comfortable using this method of char and got them to sign off and approve the Kalashnikov panel, even though they did not have the fire test rating. Since then, they have gone out and got their E119. And so it should be much simpler for anybody that wants to tackle this. And it was good kind of confirmation that what we were saying was not crazy, but they now have the test.
This Adam is where this team is so amazing, because at the same time we were in these tense meetings on the phone, how are we gonna deal with the test? I was like, well, I just sat through 5 fire tests in Sweden like 8 months ago to do the next code thing. And I've got these like preliminary drafts, like only preliminary, but will they do you any good? Like, yeah, we'll send them to the city of Seattle. So we put it together in the report and
Yep.
it was just one aspect, but it wasn't.
So that was a big one.
Speed of construction. So a couple snapshots here. Couple key things to note is, again, with mass timber going up this quickly, bringing the lateral system up, we would drop in roughly 3 floors at a time. So you can see the steel up ahead of the timber going into place, but 2 floors below that, you see the perimeter walls, and we panelized all the exterior walls. And when we put in the 2nd floor, it took a full day to lock in the perimeter. But by the time we came up the tower, in a half a day, we were enclosing the perimeter. A lot of that is pre-planning and strategy. That allowed interior trades. You can see framing going in on the first 2 floors. And all of that work is basically chasing through the tower. All critical things to kind of pre-plan and created some opportunities with SCIF.
Yeah, and to, follow up with the speed of construction, this with detail, made that install super quick. Especially when you start to, look at the tolerances, and when you increase the tolerances a little bit, you start to, it starts to get easier to put everything in place. I believe the 2nd floor, our install team put in 43 beams in 5 hours, I believe it was. The entire level of the second floor. So it was, again, we've simplified the detail and it makes it so much easier to actually
That
install.
joint occurs, is it 410 times or 510 times? It's about 500 times in the whole building. So, and each one of those joints has 1, 2, 3, 4. Okay.
Yeah, I mean, you have, the only difference between the joints is one is at a 2-hour rating and one is within a demising wall. So there's just a slight difference, but it's still mostly mortise and tenon joint.
One of the things, even, you talked about the demising wall, one of the things that also this fire code needs to catch up is an important comment, because prelim drywall needs to be within 4 floors of your active floor. So within a tower, there's a lot of things that you have to think about. We'll discuss, but that's fine. I just wanted to mention that. Hopefully it was a question.
Yeah, so this BRB frame, we talked about a little bit, we're running a little bit low on time, so I'll speed through. The welding of the column, slice is not trivial. So, we have been thinking about what it would look like to oversize your column and come up with a bolted connection or some other way to streamline that, because it slows you down a lot. So we have some ideas and I'd love to brainstorm with anybody that has anything.
If you don't mind, there's a question on the Zoom chat.
Yeah.
What is the difference between standard steel brace versus PRB?
Great question. The simple answer is that a standard steel brace is just a tube that you weld up. Maybe it's bolted, maybe it's welded, it's probably welded. And it's designed to, act in tension or act in compression. And in high seismic zones, when it acts in compression, it is designed to buckle. It's intentionally designed to buckle. A buckling restrained brace frame is a very high strength steel element running through the middle of the frame that acts in tension as all steel acts in tension. But when it's in compression, it wants to buckle, but there's an outer casing around the whole thing that is not allowing it to buckle. And so the outer casing that you see here in kind of the red color is actually not taking any load. It's just making sure that that inner core doesn't buckle. And so that's like an outer tube of like 10 by 10, 12 by 12, 16 by 16, something on that order. And then they fill it with high strength grout so you can find that inner core.
I love working with Adam because he explains things so clearly. I learned so much every time I heard him.
Good question. So another big point on these steel brace frames is we like them in general. We wanted to come up with a bolted collector detail. So these long plates that you're seeing in the upper picture, the red plates are collecting all the seismic mass of the building and pulling it in and delivering it to the brace frame. And so we wanted a bolted joint to make that work. You see next to the wood column there that's wrapped. We had to router out the bottom or router out the top of the panel so that we could fit all of the bolts. And that was, I think, largely a good idea. And I think it worked pretty well. There were some hangups. There's the plate in general kind of screws up your acoustic rating a little bit. And I don't think it's perfect, but I think it's generally a good idea. The biggest lesson learned that I would add is that at the column, we have this little tab sticking out that's welded to the column. And this is a lot of force that has to be delivered in a very small area. And we're like, okay, we need 6 bolts. We're not going to get 6 bolts to the column. So we're going to weld the tab in the shop. And then we're just going to have the 6 bolts go to the plate. And we thought, okay, you should be able to router out the panel and like slide the panel underneath that welded tab. And
It doesn't work
And it
as
didn't-
well in person.
yeah, it didn't work.
In the model, it works great. Yeah.
Well, I think that's the point, right? You think about details when it's in its final state, and I think what we've learned in mass timber is you got to think about that transition.
Yeah, having to try and basically place that panel at an angle in order to get it underneath that tab, while also considering, oh, you have holes in that same panel for like 2 other columns down the line. You can't bring that in a manual, like, you need to, like, either bend that tab or re-weld that tab back on, in the field, and yeah, that was just one of our biggest hiccups, and it happened, you know,
Yeah, we thought we had it all figured out,
all
and
good.
then we cut them all off, and we welded them all back on.
And that's just, you know, one thing, we don't like to weld on site, here it would, but yeah, it's just.
Yeah.
Yeah, this was in terms of lessons learned, this was a key piece of our really, really early discussions with Timberlab and Swinerton about how much columns and the chart depth to talk about to express. I'll just go through this really quickly, but you can see these exposed columns in the entry as you're coming in. These are all our PPs. And then these are narrower columns. And one of the things I think we did right, but I think it's also a lot of discussion with this team about what are the pros and cons of that, is that we saved fiber, as Megan mentioned, which means we saved column costs, which means the detail looks like this. So there's a lot of the 2-hour graphing is not taking hard depth, it's actually taking gypsum wallboard versus the exposed column at that point, which is more fiber, obviously, but you have that char depth in there. You can see the section that it relates to the CLT panel in both cases. But what that allowed us to do was then to run the RCPs, all it's a soffit with the exterior ventilation up in that corner, cover up the bathroom, cover up the soffit in the kitchen, run that ventilation out to that corner, and you're not really covering up any wood. So we were able to organize the units in a way that made sense to expose all of that wood, all of the ceiling. And what you're also seeing here is tracking the amount of soffit. People talk about, oh, we can expose 100% of our ceilings in mass timber buildings now at type 4B up to 12 stories. Awesome. You're never going to expose 100% of your ceiling in a residential building. And so we're getting 66%, and I think we get 74% from one bedroom, but we never even got close to it because we were tracking it. At the same time, we're worried about how much cost it's going to cost Swinerton to cover up that ceiling when we do have concealed soffits, because we know there's that concealed clause that everybody loves in the code, and you've got to either stuff it with insulation, put sprinklers in there, or cover up gypsum wallboard on that top layer as well as the lower soffit area. So there's a lot of extra dollars in these soffits, and we want to expose the wood anyway. So one of the lessons learned is just track the RCPs, and to do that, you got to know what the panel system is. So it's a really, really agile team that can handle that all in very early feasibility and software and schematic.
And because of that encapsulation, we were talking about that being within 4 floors. There's some argument, and even within our team, there's differing opinions. And that's why Adam and I always like look at each other and smile when we talk about this, is because there are different opinions about whether that encapsulation strategy worked. Reality is there's a number of other factors that go into that decision beyond just timber structure. So you can have timber expertise in what's efficient for timber and install, but if there's a way to take benefit, as Susan pointed out, relative to the mechanical system, then you can start to see what we're always looking for in mass timber buildings, which is complementary benefit. It's really 2 things. You can cash the check twice. And so that really organized well, but this also then becomes a stepping stone relative to type 4B applications, because there is these encapsulations that occur. And so it starts to help inform a future strategy is how this is.
This is a similar comment. I've been talking a lot about this connection here that, you know, is amazing, this wonderful all-wood connection. But to even get to that point before we were actually designing the mock-up, there was an incredible work with the code committee of the code at SBI. And I can't emphasize this enough, especially for the architects in the room. Get in, talk to the cities early. We were doing this in design development. We had probably 2 months of meetings with SBI to go back and forth, because again, we had helped write these codes to say, oh yeah, when you have a column and you have a beam or you have a next to a wall, that's joint's got to be sealed, because otherwise there's oxygen in there. We had a test in DC in 2017 that showed a delamination, and we were freaked out about a little bit of airspace. And so to even get the city of Seattle to agree, to understand, we had the language in the code, but to apply it to this site condition, this built designed condition, was a totally different interpretation and clarification that had to be done. It hadn't necessarily written to the letter of the law. So getting in there and getting the SCDI, who were great people, really wanted to help us make this work. They needed to, since they're very rigorous, to help us determine where that eventually is necessary to go, on which surfaces and how much of it, of course, as little as possible, for cost reasons and install reasons, but to give that to an agreement that we could then proceed and submit our building permit plans for was a huge effort. And it allowed us to do this building as a right without any engineering judgments. The only fire testing we had to do was that coalition piece. And that was things that were out of our control, but we were able to get this building permitted as a right, which means we can repeat this building easily, again, across the country in any jurisdiction that adopts codes at type 4.
Again, I'll try to keep this short. The column-based detail I absolutely hate. I feel like I've done it like 15 different ways and I have not found a great way that is adjustable in the field, like easy to install, easy to fabricate, and looks clean. If anybody has any ideas.
Well, we find that some are better, and others probably wouldn't. So,
Yeah.
but I think
I feel like this is middle of the road, like, not terrible, but.
it's not totally
And
bad.
keep in mind, just for the designers in the group, these are all going to be covered up. Because we have to seal all of our combustible structures for the type we'll see on the exterior. The way this is an exterior piece, it's all going to be covered with HAR, which, you know, is a nice material, but obviously we'd like to expose that wood, but we're not allowed to.
But in the interior, it will be exposed.
Yes. I'll give you where from you. I appreciate it.
There's give and take in every good team.
Yep.
But just some celebratory moments. It's always great to see the work and people helping to get it there and put it in place. You know, at the end of the day, smiles from the team, including the ownership structure. Really kind of thank you for the opportunity to share. Obviously, we could talk for days about this project. We try to compress it in, appreciate the patience relative to time. But we can go to a Q&A piece if that makes sense. Or what do you think?
Think of it.
Yeah, no, we can go straight to discussion if you guys like. Sound like you were gonna say something.
There's a couple of questions on Zoom, and I just want to remind people there are adult beverages. If one needs one, I would like, not just need one, but you'd like one.
He means he wants to.
So one of the questions, this is for you, Adam, Scott and Lewis asked, what is the seismic rate of this structure?
Rate, rating.
I think maybe rating.
So it's in Seattle. It's seismic design category D, which is generally like high seismic. There's a few that could be even higher. There's E and F when you get really bad and bad soils and stuff like that. But generally, it's quote unquote high seismic, I guess. That's a good enough. Feel free to weigh in with more questions on that if I didn't. Whoever really.
Okay, so let us know if you have a follow-up question, but there's one more from Benjamin Stinson, and it's, can you elaborate on alternate 2 layers sealed space sprinklers and insulation?
Alternates to them?
Yeah.
Do concealed space.
No, I think it's soft drops and then Brian's been texting me as well on the same subject, so that's our other.
So you want to know what are the alternates to those?
Yeah.
Code book, there's four methods. One is the actual piece of drywall up there. Second is insulation. Third is sprinkler. Fourth is not doing.
Yeah, fill it with.
Well, that's the insulation. Fill it
Yeah.
with
Yeah.
non-combustible material. And there is probably very little chance that code area would be overturned. Because there's extraordinary sensitivity to that. Why it's better just. For the moment, at least until there's been extensive testing, and there has not been extensive. Problems. Here in the fire.
Are there any, feel free to just voice a question here too, if you want, raise your hand, anything. I might start us off too. I was wondering about the exposed stairs. This is kind of just a really basic thing, but is there gonna be any kind of like tread protection on the stairs, or is it?
Yeah.
Okay.
There's a nosing, and they've already been.
And the handrail is going to be, guardrail is MVP, but the handrail is.
But the main tread, it's not protected, it's just the nosing and
Just-
a.
And it's
So
a
it's
flat,
like clear coat or something.
yeah, it's a flat. Right, plywood.
Yeah, it's a two coat Sanson, and we did UV because we knew it would be exposed to weather while it was on site.
This is Taylor Cabbage. She's giving us hands like. I think she's
Project manager.
project manager for Timberlab.
Yeah, Taylor's awesome. As a lawyer, it's been so fun to work together, but also on that, those are excellent. They're not features. They're at the back of the house, go down. We hope people will use them more because they also.
Well, I think they will be used more because you have the laundry on every other floor. So we actually talked about that. There's this instinct to say they don't matter. Because we don't like to use stairs, or the stairs only get used for one, from the lobby up one floor and everyone gets tired. But I think on this project specifically with the shared community spaces kind of throughout the floors, I envision them getting used a lot more.
We hope they are.
Yeah.
I really hope they are. It's gonna be beautiful.
Should have sat in on the actual meetings.
I'm all on board. Yeah. Well, we can talk afterwards. Maybe we should change the plan for the finished material here.
Got a question in the back of the room.
Sorry, I was a little late, so I'm not.
Can you stand up?
really covered at the beginning, but I'm curious, especially since you had a cash flow slide in your presentation. And I saw some information online about like the grant, the conservation grant, like how much does that feature in the project budget or?
The grant was $250 million. And so it was key because what it did is it allowed the owner to take the incredible risk as a nonprofit to go forward and to say, we're gonna do this project, even with mass timber as workforce housing, taking two risks to this owner. They're doing a workforce housing project in affordability context, and they're also doing mass timber. And what that allowed was to get us through a really, really robust concept feasibility study, which was essential before we even got to schematic design. So this was pricing it and with Timberlab's input. Actually, that was even free to back in this window there. And then we were kicked off to do schematic, and that grant covered some of that. But it was really to tighten that cost estimate and the project down. 6 or so months, we got them up. And then I think it was ready to. So it did help, but in the big picture, it was a tiny microcosm.
And so for the, I guess, majority of it, was it like grant or?
The rest of the funding?
Yeah.
Yeah, it was, it's conventionally loan financed, with a conventional bank loan mortgage, AP, our incredible development, led that portion of the project. And then, this much would not have happened without.
So outside of the wood innovation grant, there were no other subsidies at all.
There were no public studies.
It's just like a private developer went develop this project. What the Wood Innovation Grant did was help study and develop the feasibility study. And really, for them as an asset, 80 or 88 units was really what was squeezing off the site, building it out of lighter frame, getting to 126 units makes it work operationally for them, because they know that they need to be above 100 units to make building management work, building maintenance work, all the other things. So it really gave them the confidence to take that leap. That's really, is the case with every pivotal project that happens in Mass Timber, but then it allows us as an industry to kind of bring that back and further opportunities in the market.
The question is, you elaborate on how the unit count was increased.
Yeah, we did a 5-story study in the feasibility study. And we did, it was all language frame. And that was the direction of our owner, who didn't want to deal with the grades, having the concrete on site. And so at 5 stories, we were able to get about 80 units, which is something, but not a lot. Obviously, went up to 8 stories, we went up to 126. And that begins to make the vision work. We compared the last 2, even those two IRRs for those two particular performance, the 5-story to 80 units, the mass timber and 106, even though there's obviously additional cost for the mass timber, they were almost marginal. They were a little more mass timber was, but the decision was made to go ahead with the mass timber because it was marginal, and there was also the hope and the promise of the excitement that we would be able to lower the schedule savings, which would then bring the cost even more into line. And as William talked about, that really was highly.
I have a follow-up for Stephen, if that's allowed. Am I allowed to ask a question? So if, now that we have, 2024 rules allowing 100% exposed in type 4B, would we have been able to go taller on this site with the exact same building? Or
No,
we capped it
because
at
the zoning was, so the zoning had been raised from, I think it was 5 on that site up to 80 for MHA, which is a Seattle thing. And it had just been raised about 2 years before this project, maybe a year before the August of 19. This zoning. So we had a zoning cap of 80 feet, and the city of Seattle was very strict about their height restrictions. And nobody goes in and wastes their time asking for extra height unless it's been stated. Waste time using. So 80 feet was up. We were able to max that out. And proceed.
I have a question. This is from Bradley Stenner. Can you briefly discuss any specific supply chain challenges in the Pacific Northwest region moving forward in
2023, that's the key. I saw the eye roll from Taylor.
I'm not saying
We had a lot of supply chain challenges, but the 2023 is the key. Anybody can answer?
take it away, Dave.
If you want to build a building in 2023 with mass timber, you're not gonna do it. Most of them are all sold out through 2023 at this point. You're into 2024. Those deposits that William kind of highlighted are critical. We used to say they're critical for price security, which they 100% still are. When you lock in that deposit, you stop the lumber price from going up and down for yourself. You get to hold on to that. But what is becoming even more pressing these days is the availability of the timber and to be able to get into somebody's production window. And right now we're seeing that to be about a year out.
For
You know,
large projects.
on big projects, you know, when you're getting above 40,000 square feet is kind of when you need to start thinking about it that way. Obviously, if you're working under 40,000, you know, people love those projects. You can kind of squeeze them in and fill production holes in between the big projects.
I would say, I would add one more thing to that in that. That's part of what we started to see with closing the crop on this project. Because even though the concrete strike was pushing us out. We had an opportunity because we were ready. And they had a manufacturing window open, so they went ahead with their manufacturing. And so we got into discussion, but that's part of why you saw that dash line go into Spokane for holding. And that's something that the team can take a decision on as well. Even if this is 67,000 square feet, but it's further exacerbated as the industry has accelerated. So these are things that are top of mind and being discussed. And
Then I have a follow-up there. So how do you guys think capacity or new supply is gonna change this year? I mean, Mercer is a pretty big operation for production capacity, right? And then you have Sterling, who hear all kinds of, you know, production efficiencies, but maybe they're too far east to be influencing the region. What do these guys think in terms of?
And there's another input is that structure land just shut down their parks.
Right.
Just as of yesterday. There is a lot of dynamism in the market, certainly, but on the other hand, from this part of Alabama. And a lot going on.
so there's a number of answers to this. Taylor, do you want to start anything? And I'll kind of color in with
I mean, we're really seeing the pinch points in the market being the CLT and the fabrication of the glulam, the CNC machines. There's only so many CNC machines that exist in the United States right now. There's only so many CLT manufacturers who have good supplies to lumber and have availability in their capacity. But typical glulam, you know, it's still pretty abundant. It's still pretty available. We've actually seen some jobs go to hand fab. Not through us, we're lucky enough to own some CNC machines, but other places in the market are transitioning back to hand fab because of that. But of course, that gets really difficult when you start talking about fire ratings and things like this, those buildings that are up at those levels kind of need that CNC to make it viable to work at that level. So depending on the project, there's a lot of beautiful projects out there that are existing that are 1, 2, 3 stories, and we're not seeing, like I said, that tight pinch point in the market. We delivered a project thesis around the corner and we did it in 6 months or something. So we totally busted what I just said. But it was the small,
It's
a small
40,000
project.
square feet as well.
Yeah.
And I think, and that's one that, as we looked at it, we came in later to the process. So we didn't have the opportunity for detailing during CD phase, which is typically when we like to be doing that, working alongside the architect and engineer. But we looked at how we could take a methodology and approach to meet the client's schedule and really deliver it 4 months faster than we ended up competing with 2 other general contractors here in town. And our schedule was 4 months faster than one and 6 months faster. Part of it was us understanding both how to build the building efficiently, but also having Timberlab understand the kinds of decision points you have to take to make the kind of pace and kind of break the rules, because it's kind of like what we like to do into the delivery project. Relative back to the supply chain, I think some of the keys the overall capacity, we started to see that pressure with Bliznikov earlier last year, like a year ago, I guess, when we started to see that typically you go to Bliznikov and all of our panels are SPF. SPF started to became unavailable because their harvest, they didn't have spruce pine fir, so everything they're doing currently is Doug fir. And so it can be in species, it can be in fiber sourcing. There's a number of people through the manufacturers that have been focused on fiber sourcing and predicting what we're starting to see, that it really looks like 2023 and 2024 are going to be supply chain constrained. And so it may reopen Europe. I think a lot of times we want to work within the Northwest Cascadia region to the greatest extent possible because of the really accentuating the carbon benefits. But we may be looking back to other creative sources. I think the other beauty of Timberlab, just to pitch Timberlab in a way, is that slide that Lauren flashed up, it talked about CNC ability, detailing ability, all of that. Part of leveraging the supply chain is having a partner in a project that can supplement the capacity of any given manufacturer and maybe bring people to the table that otherwise wouldn't be able to participate because they don't have CNC or they don't have.
Oh, yeah, I had a question. I think I just answered it. Is this all Doug fir based?
Doug fir on the columns and beams, but spruce pine fir on the SCLT.
You might have noticed a little color difference between the vertical and horizontal beams and columns. They're a little bit darker, a little bit oranger, and then this pine fir on plates on the underside.
The bottom photo would be perfect.
That's a little almost exaggerated, maybe a little bit oversaturated, but it's a really sweet and differentiation structure.
Weight savings for horizontal aspect.
No, it's manufacturer availability and the spring properties and performance that Adam is going to improve the aesthetic that Atelierjones.
I actually sweated over this decision a lot.
I know.
Too. It was hard, but I like it. I like it a lot. I like it more than I expected to.
So the SPF is cheaper. So like we want to start at the light by default, but nobody's gonna make an SPF blue lamp. The cheapest building is split like you see. Like if you are committed to matching the wood, you're gonna pay a little bit more for it. But it's also stronger, so structural engineer is not gonna complain. But I don't want to be the one saying you have.
And almost all the work I had done before had been in SPF wall, SPF wall. And it's a beautiful volumetric expression of a very light skin feel. This one was not going to have that, but what this did is it really accentuated the volume. Sure. structural muscle of this project. And I really like it. It looks. I like it a lot.
But the beauty of the SPF as well, there's the lighting, a lot of projects have taken advantage of having the lighter wood and getting a better balance of light and I'm gonna stop talking there. It's smart presses. So anyway, question in the back.
Yeah, just had a quick question. Being in Seattle and probably not being able to only build in the summertime, there's rain, there's a lot of moisture and things like that. And with CLTs just being naturally exposed, that's the whole benefit of them. How much refinishing do you have to do after the fact? Like, do they get
We
wet?
anticipated your question. Put this in, but what you see here is we put in a wet deck on the 4th and 6th floor, and that was probably one of the most painful aspects of the concrete strike and what it did to the disruption to the front end of the project. It also pushed our install from a perfect summer build into the winter. And so what we did was we, I think it's vapor shield, right? Has a material that they developed specifically for shielding the water, but we learned a lot even with what we put into the wet deck on the 4th floor versus the 6th floor on roots and columns and other aspects of it that allowed us to kind of get temporary dry until we get to the roof. But there is going to be water intrusion, so water management is definitely part of the plan. We've also found some really good natural products that can be spray applied to the wood to address staining and other aspects to finish it. It's not, you do not want to do like sand chase. It's one of these things that it starts to distort the surface of the wood. But I think it's something that's very top of mind. And a lot of the things we've brought up have been things that the team wants to talk about and come to a common solution relative to it. I think even that aspect of it we talked about.
Yeah, I was gonna say that I think the market's really divided on to coat in the factory or not to coat in the factory. I think this is one of those things where if you put enough of us in a room and enough drinks, like it could get really heated. And I'm gonna try to stay completely neutral and not put my opinion in it, but well, I used to be in one camp and I changed the other, I guess is the really interesting thing. I would have said, let's coat it in the factory, let's get as much sealer and protection on it. But the issue is, as you know, William pointed out, it's gonna happen. Like, it's inevitable. It's even gonna happen a little bit more when you have, unfortunately, as great as this buckling restraint brace frame is, having welding that exists on your site in steel, you're gonna see some staining that's associated with that, no matter how HEPA filter vacuumed you stay on top of it. And having the ability to come in and clean the wood easily and then not be fighting a coating that's potentially already on it is also a good, I think, a pretty good option as well, just to kind of keep in the back pocket. This project has a sacrificial 1-layer coating to the glulam. CLT has no coating, and we're gonna be able to go in and pretty easily clean this up. I have a project that is 3 miles away in Seattle that's going up next week, and everything in the building is coated, 2 coats. So we're gonna run these 2 next to each other, and that might put it to bed.
See, that's been more of a, do what's natürlich, right, Mark, so I've been here a couple times, ever with questions. But I've always been about no sealers on the surface of the wood, just the dissipating sealer on the glue lamp. And you always seal the ends of the CLT. That's something we do because it's a vulnerability, but that's easy to do. Trying to seal CLT before it comes to the site, it's just not gonna happen. It has to be a field applied sealer, and you're starting to defeat the purpose of the sealer at that point.
One thing that I learned from, I think it was Thomas Robinson, on a presentation I gave a few weeks back, that like way back in the day, the recipe for ink was like iron shavings and wood lignin and water. And so like when you weld on a mass timber building, like you are literally creating ink, like, and it will, so figure out a way to protect your wood if you want to avoid a pool.
One more question?
Yeah, you can take it. No, we're coming. Sorry.
So when it comes to construction, those units or the panels are prefab. Do they come from the source and then ready to install, or do you have a lay down yard somewhere that's close to where you have somebody shaking them out?
This is the lay down yard right there.
Yeah.
Right, and every night, this only closes during the construction window. At the end of it, and it has off-duty police officer that basically stands there the whole day when you open it up to a truck. At the end of the day, that turns back into a pedestrian path to reactivate the sidewalk path down 14. So that is the lay down yard. That was the window between the tree and the L&B building. And every panel basically is both logistics, placed, and basically it locks into place, sits on the edge of the deck and installs as it goes in. So in a half a day, that whole floor, all the way around, everything you see in Den's on. And
It
it's
is
already,
so cool to watch. That truck pulls up, the policeman doing its thing. There's 3 guys immediately on top of that panel, boom, 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 boom. And then there's somebody, the crane's coming in, they hook the hooks on there, the panel goes shooting up and goes over and lays down here. Then there's 3 more guys up there. Those same other 3 guys are on the other one, putting the embeds in there, waiting for the crane to come back down, the panel's going up. They're putting that one in, but it took about 6.5 minutes, I think, per panel, maybe 5.5 minutes per panel to get it on. And that's a big, long panel. Those are 48 feet
you're
there.
talking CLT, he's talking, I think you're talking perimeter wall, or are you talking CLT?
No, I was talking about the entire project.
It's
It's
all
like a
just
tinker's
in
way.
time.
Yeah,
So it's just in time for coming from the source on the truck and
It's
install.
put in, takes off, another truck pulls in.
Having to schedule
It's
every
amazing.
single.
Well, it's not it's not from Kalishnikov, the source.
Well,
Right.
it should have been, it should have been.
Should've
It wasn't because
It
you
just-
couldn't, but it came from Spokane, which is arguably not any further. Or any closer really.
yeah, there's still some snowy passes that you find at the end of the.
Yeah, the unfortunate thing, but I mean, that is the beauty with the CLT specifically, the CNC capability, if that's what you wanna do. The only people who own CNC machines large enough to do panels are panel manufacturers. So we want it to be fabricated by them and shipped by them to our site for just-in-time delivery. That's the goal. Obviously, the longer and the further you get away from your manufacturer, the decision about that logistics changed. I can tell you from doing this on 20 projects or more, you don't want to double handle a CLT panel.
Right.
Like, it's heavy, the likelihood of damage is high. Once that wrap that's on it gets damaged, water is now getting trapped inside the wrap. The CLT is just too big to want to double handle. Glulam, totally different story. There's a pretty good reason to want to put maybe a store yard or a stockyard nearby and pull. We didn't on this project because obviously Timberlab to Seattle is a jaunt of I-5.
Here, Timberlab,
Yeah.
post-processed and then delivered. Unless you got the panel went from there, they got all the processing done up there, and they had to hold the schedule, then they delivered. Those trucks arrived just in time, so it's a.
And the manufacturer put them on the truck and had the trucks lined up with your delivery schedule.
Yeah.
That's part of the trick right there.
Yeah, you want the mass to, for CLT, you want the supplier to be responsible for all the trucking.
So every Tuesday morning at 7 a.m. There were, Taylor, Andrew, who was their field install, superintendent on the site, Matt, and Gail Roberts, our project manager. We got together and we talked about it. There was a schedule of truck deliveries. I mean, it's just like you would do. I mean, for us, we look at it, even though it's an 8-story building, you start to think, oh, I'm gonna build like a podium project, right? Or I'm gonna build it like plywood frame. It doesn't work that way. You have to think like I'm building a 20-story tower in a downtown situation. And it's like, how do we coordinate truck deliveries? How much time do you need to hook? And it's all about hook management, where you try to think about how do we put this in and get the piece where it needs to go and release the hook, get it back to the truck like Susan talked. Again, the architect talking about low logistics, integrated team.
So you had mentioned that you were, during your bid process, you were 4 months ahead of the other people. Was that because of the project you've done, to be able to look at and say, we can do this load at this amount of time? With your
It
solar
goes back to our
panels,
first mass timber project, first meetup we talked about it, was First Tech, but Federal Credit Union out in Hillsborough.
Right.
When we did that project, we delivered that 4 months faster than structural steel. And the reality is, we've always seen the opportunity for speed on mass timber through pre-planning. It's like 90% effort up front. Site, that's what we're putting. And the reality is to continue to build off of that, now having done over 25 mass timber buildings, Now I'm over 40 in design, and those are old stats, 6 months old, so I know it's higher than that. The reality is, having that and integrating the team, we take the same approach. This team expands out to trade partners that are involved in mechanical, electrical, plumbing, envelope, beyond just the Timberlab partner. Timberlab and the mass timber frame becomes the chassis for the basic project. But it's really understanding how those go together, leverage the strengths of all of it, what helps complement the speed.
Can I ask a general question?
Let me give the back of the room an opportunity if we haven't answered your question, but we'll come back. Did you, yeah, you had a question.
Yeah, it's kind of along the same line of speed too, like you talked about the joinery aspect of all the columns and beams, and I'm wondering. At this scale, it probably was pretty sweet to have that quick assembly, but at what scale would that become like a hindrance, like? Or could you just scale it up as big as you want to go?
Scales up and down, the speed's beautiful. I mean, I look at Andrew and I think about Shemekia Community College that we did together, where the structure went up in a day as far as the MVP panels. And so it's like, you know, that's a game changer for projects. And that's a one-story building, and it's really how do you work together to integrate that. And I think, you know, and that's where I say, I look around the room and I see a number of friends within the room of working on the challenges. And so that scales at that level. We're looking at much taller buildings. You know, Taylor worked on the Ascent Tower in Milwaukee, Wisconsin, which is 25-story. And just the speed of that one. I like to show people a picture of the concrete cores where they're 10 floors ahead of mass timber. The mass timber still caught the concrete before they got to the top of the tower. And you start thinking about, you have to think about buildings differently in their delivery. You really have to think at a builder's level. For me personally, that's what's made this so reinvigorating to something as I'm, 35 years into my career now, to see something that makes it all new again. As we said at the beginning, having the challenges, the puzzles, make it exciting.
I would caveat it a little bit, and I would just add that you wouldn't do a mortise and tenon joint if you didn't have a 2-hour rating. There would be cheaper ways to get that building to still look all wood without that effort, without that level of detail. And so I think the scale is not like the square footage of the building, but at type 4C and above, everything's 2 hour. But if you had a building that you could get to a no hour rating, you wouldn't bother with any of that. You could simplify it. And so it's not quite just like it's always applicable. If you're building a single family house, you wouldn't do this joint. You would come up with something better.
Yeah, and I think maybe I misunderstood the question as far as the scale of building.
Maybe I
relative.
answered a slightly different question.
Yeah, it's relative. I don't know. Always applicability or simplicity of connection, but I think that's the thing, is like talking through those options early in design is really what comes. Back to you now.
Yeah, so it's more of a general question, not project specific, but it's around mass timber. So my understanding that the US mass timber market represents over 15% of the global mass timber usage. Here in the States, only 1% of all structures built are actually mass timber structures. So I'm kind of curious from your professional opinion, what is precluding the rapid growth of mass timber market, given it's all of these phenomenal attributes it has with offsite construction and prefabrication and the like. I hear a lot of kind of like there's obviously supply and demand issue. Maybe you could elaborate a little bit more on that, and then other things of the market.
Yeah, there is
We'll also take that.
that's I'm looking at Ian because this is something that we've been wrestling with for a while, 6 years maybe. But I think part of it is, I like to tell the story this way. When we built First Tech, at that point, 7 years ago. 7 years ago. We had 90% of structural ounce capacity in Penticton, their Penticton plant, and they were the largest producer in my mind in North America. Atelierjones was up and running, but their capacity and ability to manufacture was much, much lower then. And so if you weren't us, we had 90% of capacity for 3 months. And so if you weren't us, you were waiting for us, right? And we were like doing the largest in the US at 156,000 square feet. And that was the nature of the market at that time. The following, a year after we completed that, so 2 years further, we had 5 mass timber projects. And when we went to place those in the market, we had 4 North American manufacturers on CLT, but the 5th one, no one had capacity. But people had tooled up, so Structural Lamb had tooled up to be able to supply the market more. But we couldn't source the 5th project from North America. And so that project ended up being KLH. And that's where Europe kind of came in to kind of leverage into that situation. And now you're talking about the rate of mass timber buildings going up is further constraining the market. And so it's a constant look at where are the constraints to the supply chain. And so the study we did 2 years ago, 2.5, yeah, 2.5 years ago, because it was summer of COVID, right? The summer of COVID, great supply chain study put together. Towa Design Institute, as well as Business Oregon, great writer with Alex Atelierjones, who's he's really long in the tooth. I think he's older than you in the mass timber industry.
He is.
Yes. But great individual, put together a supply chain study, and I had the benefit of being kind of like an industry resource. But it really looked at what are the constraints to the supply chain. But you know what? 2 years have gone by, and so we're in a different market, and there's different constraints and choices being made by manufacturers, like Susan alluded to, Structural Lamb's decision to shut down Arkansas's the plant in Arkansas. There are other reasons why that's occurring. But Pierre Johnson is also kind of taking a step back. And so that's creating a little bit of a pinch in the market right now, but the market is resilient, it will respond. And just like Structural Lamb having 90% of their capacity, they went back and looked at their internal manufacturing and increased their capacity because they saw the opportunity, the success of First Tech and what that was going to mean to the industry. So we need to continue to look creatively at how we can combine those resources that are available to us to continue to allow the market to grow, because the reality is mass timber, we're going through this on a number of projects. We're working with KPFF on a project at the PSU where we went through the same studies we're doing on a lot of projects. So should it be mass timber or should it be concrete? You know, what are the structural options? We do that often with Adam's team. And so it's really, you know, it's great that mass timber is becoming more mainstream, but now we need to make sure that that supply chain is supported.
I think to add on to that, you quoted 18% of mass timber is happening in the US. I feel like the answer to that is because we are far behind Europe in the adoption of mass timber, and they are so much further ahead in the way that they fabricate. They're so much further ahead in the way that they like the volume at which they can put things out is just a lot more than us because they've been doing it for so many more years. And because they've been doing it for so many more years, all the contractors there know it and understand it. Nobody goes to meetup groups trying to learn about how to build with this stuff because it's just part of their, like, it's just another tool in the toolbox. And so as we are figuring it out here, I think that it's been like we've been going through those growing pains. I feel like a lot of projects that I don't have the opportunity to have Swinerton and Timberlab on, especially in the middle of the country, you get contractors that are like, yeah, we're excited about mass timber and we've never done it before and we don't have any historical data. And so here's like a 45% contingency because we just don't know. And it's like, well, actually it's cheaper to build it in concrete. It's like, well, no kidding, you know? But if once we have the data, once it's more adopted, I feel like those things are going to go away. And we're starting to see them go away right now. And as they're going away, people are becoming more interested in it. And as people are more interested, more fabricators are coming along. I feel like we're talking in the last, couple of weeks to a couple of months about some fabricators closing their doors. But you know, if we
Nobody on that.
Zoom back.
existed,
Yeah,
when I was
exactly.
trying to
You
sort
back
out-
up 5 years and you only have one source, right? And now we have, we're picking from 15 sources. And maybe in the last 2 months, that 15 shrunk to 13. But I feel like we're still definitely on the growth trajectory in terms of adoption.
I'll never forget, Adam, when I taught a studio at the University of Washington on mass timber in 2013. And I was all excited, these great graduate students, and we're, oh, we're gonna learn about mass timber. And there's this really, really lovely Danish exchange student, and she said, I'm not quite sure why I'm here. I like the studio, I like the school, I'm really excited, but I don't know why we're doing mass timber, because we just go to the hardware store and buy it, kind of the Home Depot of Copenhagen, but if, I mean, I'm here to learn, and she was awesome. She did the most lovely project for the whole studio, but that was only 10 years ago. And Europe has been doing this for 20+ years before we even heard the word.
Yeah, and I would also add in a slightly more positive note that, I mean, maybe it's just like the US mentality, but I feel like we are going to leapfrog. And like the innovation, that the fact that we have an 18-story building like in the code right now, and my company has a permit for one in hand for an 18-story building in the Bay Area is like unheard of in Europe. Like you would never build that building in Europe. And so the volume at which they can put out is way bigger, but like we're going out and doing the tests and trying to figure out, okay, can we get to a 3-hour rated column? Like that's not where their head is at. Their head is like in the single family and in like, you know, small little boutique apartment buildings. And I don't know, it's, again, maybe it's just like the American
No,
mindset.
I think we saw, yeah, I mean, there's a couple of different points. The 3-hour fire rating makes me %. But on the flip side, I think about where Europe is. We went to Council for Tall Buildings, there was habitats in Chicago, and Susan and I were here from Paris, starting to ask questions about what we're doing in the US with mass timber, because Europe is now starting to look towards us and what we're doing.
I would say that we're building, we like, there is a huge housing market in Europe because Europe was building housing out of concrete and steel. And so mass timber was affordably making sense as a substitute, unfortunately, depending on how you are. In America, because we don't build like small housing out of that more robust stock and we have a light frame option, there's really not a reason for mass timber to exist in that low level. So if you look at the percentage of what Europe is building out of mass timber, it's probably 75% low grade, you know, single family, you know, kind of small cluster housing out of it. And we're doing the opposite. We went right in and we're like, let's go build the tallest. Let's go do it at a 3-hour rating.
Yeah.
Let's figure out how to do it in a tight urban site.
Yeah.
We're asking a lot of these buildings and I love that because we're super ambitious.
Yeah.
But obviously going and building, you know, square box housing and miles of it would be a lot easier. And we wouldn't be having to ask and answer all these questions and prove all these things.
Yeah.
And one other context point, what was the installation crew size? Andrew had working with them?
On Heartwood. Heartwood was anywhere from 6 to 9 guys.
So you think about 6 to 9 carpenters working on a project on an urban site, trying to do that in concrete, you know, you probably be at 30 people, right? And so you think about, there's no parking in Capitol Hill. So trying to get 6 people parked versus getting 30 people parked. I mean, there's a lot of impediments. This really starts to make sense to address urban issues and constrained resources.
Quieter install,
Much quieter.
especially.
We answered your question because you struck a nerve clearly.
I guess to follow up, would the punchline be that if we were to kind of bring the supply chain infrastructure into modernity, that would would the demand still be there? Right now, there's a ton of demand with no supply, but if we were to adopt the European market, really bring the supply chain up to par with Europe, do you think that it would allow for more building growth, or do you think it would
I think it totally would, but it can't happen like one or the other. I think like it has to kind of grow in tandem. So as we continue to have demand, it's gonna encourage more manufacturers to get in and tool up and continue to grow. And so I think that's just how it's gonna have to work.
And we keep tripping over pinch points, like last year, 2 years ago, you know, kind of around the time of 2020, we were running into a lamb stock shortage, right? And it's because no sawmills want to make lamb stock. It's really time intensive, right? And it's a high quality wood and they have to do sorting, they have to do all this stuff. And when everybody was building their decks, you know, during 2020, they could sell you a green piece of lumber that they cut 2 days ago and you would buy it. And so nobody wanted to make any lamb stock and it was holding up jobs here. We only buy what, 8%, like mass timber only accounts for 8% of the lamb stock usage in this country. And so like, until we're 15 to 20%, the sawmills don't take it seriously enough to make the lumber that we need consistently. We've had screw shortages too, as well. Most of the screws have been coming out of Europe and they have to come over in containers and things like that. So we keep finding these little tiny pinch points that keep kind of just the moment we feel like, oh, we have enough CLT plants. It's like, now we don't have enough of this wood or like, and I think that's just gonna work its way out as people realize that we're here, we're not going anywhere. But I think the jury's still out.
But the gray shaded area here, you know, as far as the Cascadia region, is really supplying 2/3 of the wood in North America. And it's like, and part of what Timberlab is doing is also positioning for that other third, which is largely like southern yellow pine. And really looking at the southeast, and we see tremendous growth market in mid-Atlantic and in the southeast. But that really, both being locally sourced, being able to do the fabrication aspect there, being able to respond to that and support that, I think really starts to strengthen North America. And so these little decisions, these little pinch points, these little hurdles to overcome continue to strengthen North America's position. I think we may just find ourselves in a position where we're needing to leverage Europe to make the next step. So it's just kind of like I think
So question on the spruce fir versus fir, does spruce fir have to be part of that horizontal? Or is there other fibers that could be used to make that horizontal? It just depends on the manufacturer.
Yeah.
Okay.
Goggin and Atelierjones have done CLT panels that are out.
And Mercer has capacity, but they seem very focused on custom layups. And so I think there are other things where market forces may cause manufacturers to think about things differently.
You were looking at some beautiful hemlock CLT panels, Kalishnikov, about 3 months ago, all of our team went up there and I love them. It's actually the most beautiful panel. But that was because they had harvested a bunch of hemlock.
There's other species that are being researched. You hear things about white fir, but there's some sorting issues. White and red fir that come into that classification. You have ponderosa that has less strength properties, and I know that both the research consortiums of REACTS and the Institute for Health and Environment, both looking at those both from engineering as well as health and wellness and other aspects. So
It's really beautiful how the species reflects the region. So if you're in the southeast, it's southern yellow pine. It looks very different. Anything on that screen. Up in the northeast, Nordic lambs supplies another black spruce. Also looks. The wings are tighter. These are growing slower because tundra. We saw the same thing in Finland. I saw this fall. Very, very. It's a really beautiful reflection.
Maybe we have time for one more question and then we all break. Is there any last question?
One quick one. So you had an LCA done and
Yeah.
It's
Explain, yeah.
okay. Yeah, I was curious because there was a number in there about, kind of like a historical number about this percentage better. And I was wondering, obviously things like transportation, proximity to the fires come into. So was there a caveat that
Yeah.
it's within a certain radius?
Let me unpack that a little bit. There was a really critical slide and we did pass over it a little fast. That number came from a study that we completed in 20, and the papers were published scientifically in Sustainably in 2000. That number came from 18 buildings that we did comparative concrete studies for 8, 12, and 18 stories. And that number is only comparing the superstructure, the concrete superstructure with the field, the mass. It also has a lot of caveats. It is broken down into region, and it is broken down into supply chain of the mass timber in the southeast. So there is some of the transportation and also the electrification quality. For the production of that, it is A1, right? But it is only for unbuilt buildings. So and that number, that 43% is including sequestered carbon. So then you say, okay, well, what's our building, right? And then we are in the process of doing the same methodology applied by the same team that did this FCA, which is with the University of Washington, to compare. Okay, well, great, you guys did an 8-story building. How did you do this life cycle analysis study that you did years ago? It's a really interesting study in a lot of ways. I'm doing it. Actually, DCI is leading the comparative concrete redesign of this structure, that we can really compare those two, and we'll have super accurate foundations before. Now we're going to have really the real foundations, if you will. And we can't wait. I mean, this number might be very, but it's not. It's not. And we're thinking about doing, if we have the funding for to include end of life, also really do the whole building. That's a lot. We have the model office in Heartwood all with all that material. But material take off. We'll definitely have one, hopefully.
All right, well, so just a couple quick words before we give the applause here for this great presentation. One, we're actually going to be leading a tour. Well, Timberlab is going to be leading a tour next week. It'll be another meetup sort of theme thing. I think we have like 15 spots left. So if you're interested in seeing Timberlab, that's next Friday, same meetup site. Next, we're going to be here until 7:30, so you're welcome to hang out. Until then, food and drinks. And that's it. So just want to give a round of applause. Yeah, thank you guys. That was amazing.
I know, I would have to.
Yeah. No, I we work more than 100. Okay.